Hello everyone, welcome back to the channel. Today we are going to discuss about a new topic, that is double titration. So this question belongs to this topic, and let's have a look. Little bit data is given to us in the question. It is saying that 25 ml of mixture of NaOH and Na2CO3 is there, and it is titrated using the n by 10 molar HCl. Right. Now when this titration is done, we are using the phenolphthalein indicator, and during this titration 25 ml of HCl is consumed. Now the same mixture, the same volume mixture when used and titrated using n by 10 HCl in the presence of methyl orange indicator, the HCl was consumed to be 30 ml. The question is asking from us that what is the total weight of Na2CO3 and NaOH in 1 liter of this mixture. Now if you know already that how to solve the problems of double titration, then you can skip the first half of this topic and directly go to the solution part. Otherwise you can easily go through the topic and learn it how we go through the double titration. Now in double titration, what do? We take a strong base and a salt of strong base and weak acid. So basically here we are taking NaOH along with Na2CO3. So let's say we have X moles of NaOH and Y moles of Na2CO3 in the solution, right? So initially what we will do at T is equal to 0, just a second, yes, at T is equal to 0, what we will do, we will take the beaker and we will put the solution, right? That is the solution containing NaOH and Na2CO3. And we will add the phenolphthalein indicator into it, and HCl is added from the top to carry out the titration. Now phenolphthalein is a weak acid. Basically it acts as an indicator basically in the alkaline medium, right? The pH operating range of phenolphthalein is 8 to 10. That is, in the range of 8 to 10 it shows pink color. Now the moment we start adding the HCl into the beaker, what will happen? The NaOH is a strong base, so HCl being a strong acid will quickly neutralize the NaOH which is present in the beaker. Now how many moles of NaOH are given to us? X moles. So if X moles of NaOH are there, if you look at the reaction, first reaction A, this reaction is totally balanced. So if you look at it, the stoichiometry is 1:1, right? That means if X moles of NaOH are used, X moles of HCl are required to carry out this titration. Now once the NaOH is totally consumed, but we shouldn't forget that it also contains Na2CO3. The moment NaOH is consumed, what will happen? The pH value will go down, right? The pH value will drop because NaOH is basic in nature. So if the base is neutralized, the value of pH will go down, right? Then this HCl, we are continuously dipping the HCl into the beaker. This HCl will react with Na2CO3, right? And it will produce NaHCO3, which will further provide the alkaline medium, because NaHCO3 will give you the alkaline base, right? That means in the second reaction B, what will happen? This HCl will react with Na2CO3 to form NaHCO3 along with NaCl. Now here also, if you see, the reaction is balanced and the stoichiometry is totally maintained. Now if we are given Y moles of Na2CO3, that means it will require Y moles of HCl and it will form Y moles of NaHCO3. Why we are not bothered with the number of moles of NaCl formed? Because the NaCl salt is neutral in nature. It is totally neutral salt, right? So this is the case 1. In case 1, what will happen? We will use phenolphthalein as an indicator, because phenolphthalein operating pH range is 8 to 10. So initially we had the solution which contained NaOH along with Na2CO3, right? Here instead of writing H2CO3, it is basically Na2CO3. So initially we had both basic salts, right? Base and salt. So the pH will be very high. The moment you will add phenolphthalein, what will happen? It will attain the pink color. Now we are keep on adding the HCl, the neutralization will keep on taking place, the pH value will keep on dropping. The moment pH value goes below 8, the solution will become colorless, right? That's where the second case of titration comes, right? Okay, so in the first case, if we have to find that by using the phenolphthalein as an indicator, how much HCl is consumed, right? So if you look at this balance equation, x moles of NaOH requires x moles of HCl, and y moles of Na2CO3 requires y moles of HCl to get converted into y moles of NaHCO3. So total moles of acid consumed in the first half of titration is how much? It will be x plus y moles. This is the number of moles of HCl consumed in the first half. In the case 2, that is second half of titration, what we will do, we will use methyl orange as an indicator. Now methyl orange has an operating pH where between 3.1 to 4.4 pH it shows pink color, and in other range of pH values it shows yellow color. That is, in alkaline medium it shows yellow color, and in the acidic medium, this is the acidic range, in acidic range it shows pink color. Now the same solution which we have obtained from the first titration, what we will do, we will drip little amount of methyl orange into it. The moment you will add the methyl orange, what will happen? It will attain the yellow color, because the solution is still a bit alkaline in nature, right? Now when we keep on dripping HCl into it, what will happen? This HCl will further react with NaHCO3. See, in the first reaction, in the case 1, all of Na2CO3 was converted into NaHCO3. So by stoichiometry, if we had Na2CO3 moles of, if we have y moles of Na2CO3, it will give you y moles of NaHCO3. Now these y moles of NaHCO3, when further react with HCl during methyl orange titration, will react and will be consumed by the amount of y only, because of proper stoichiometry, right? That means y moles of NaHCO3 requires y moles of HCl, because the stoichiometry is what? 1:1. That means the total moles of HCl consumed in this titration, the total titration, that is first half and the second half, that is methyl orange as well as phenolphthalein, will be how much? Y moles here in case 2 and x plus y in the first case. So the total moles consumed will be 2y plus x. This is the number of moles of HCl consumed in the total titration, right? Now important thing is, when we do know that we have to stop the titration, as I told you that methyl orange shows pink color when it reaches the range of acidic medium. That means when NaHCO3 is totally consumed in this reaction, what do we get? We get NaCl plus H2O plus CO2. This CO2 dissolved in water gives the acidic state, which further declines the pH value and bring it into range of 3.1 to 4.4. Hence shows the pink color, thereby indicating that the reaction has completed totally, right? So in this titration, what do we learn? That during the double titration, if x is the number of moles of NaOH and y is the number of moles of Na2CO3 consumed, then the total number of moles of HCl will be 2y plus x. Now let's go back to the problem again. I hope you understood this problem, this concept totally. Now in this problem we are given, for the case 1, how much HCl is consumed. For the case 1, if you see, n by 10 molar HCl is there, n by 10 normal HCl is there, and 25 ml of volume is there. So how many moles we need to find? Number of moles will be 25 into 1 by 10, that is normality into volume into n factor. N factor of HCl is 1, so it will be 2.5 millimoles. Why we are taking in millimoles? Because the volume is in ml, right? So that means from the first case, that is from the phenolphthalein, let's say from the phenolphthalein titration, x plus y is equal to 2.5. Next it says the same volume of the mixture when titrated with n by 10 HCl using methyl orange indicator requires 30 ml HCl, right? That means the same amount of mixture, that is 25 ml of mixture, when titrated using methyl orange indicator requires 30 ml of HCl, right? The same normality of HCl. So in this case, from starting till methyl orange, how many moles of HCl are consumed? 2y plus x. So 2y plus x is equal to how much? 3. This is for the methyl orange titration, methyl orange indicator titration. So now there are two variables and two equations. We can easily solve it, and upon solving, the y is obtained to be 0.5, x is obtained to be 2. Now these are the millimoles of NaOH and Na2CO3. So if you know the millimoles of Na2CO3, we can easily find the mass available, right? Now this mass will come out to be in milligrams because we are dealing with the millimoles. So the milligrams of Na2CO3 available are 53 and milligrams of NaOH available are 80, right? And these are the masses of Na2CO3 and NaOH in how much volume? The volume is given to be 25 ml, right? Initially 25 ml of the mixture is used. So this is the mass of Na2CO3, this is the mass of Na2CO3 and NaOH in 25 ml, right? So 25 ml contain this much mass, 133 milligram. We are asked the total mass in 1 liter of the solution, right? We are asked in 1 liter. So in 25 ml, if the total mass is 133 milligram, then in 1000 ml, how much is the total mass? We can easily find. So by using the simple unitary method, it will come out to be 5.32 grams. So this is the final answer. I hope you understood the double titration properly. If you understood it well, it's good. Otherwise, just go back through the whole video again and learn it step by step. You will definitely understand it properly and then solve this question. If you understood it, good. So for more videos like this, for more content like this, stay tuned. Have a good day.